Okay, so this is Matthew Rowe. I'm just doing my maths screencast. Okay, so for the first task we were asked to do is an object moves in a straight line at a constant speed from the point 22 minus 3 when t equals 3 to the point 12, 17, 20 seconds later. Okay, so this is the point 22 minus 3, which is the starting point at t equals 3 to the point 12, 17, where t equals the starting point plus 20 seconds, so that's 23 seconds. Okay, for the first thing we needed to do was we needed to get the slope, which ended up to be minus 2 when we plugged it into the formula. Then after that, we had to get the equation. So we plugged this value here into the slope value here, which then in turn we got this value, which was the equation of the line in prescribed y. Sorry. Now, there was one thing we needed to do extra to get to this point, which was we needed to find out how many movements per second, or how many movements were in per second of the between the how many movements per second from this position to this position. Now this position is 10 places away from each other. That was 20 seconds at time. So that was minus a half because it's going in the negative direction. Now, when we have y as this value, we keep x as its original value. So this is the parametric equation form to get the parametric equation. So then we plugged our seconds per time, or our movements per second, again with our starting position, which would be the x. Now we plug our x value into our x in the y value. So then after that we get this value here, which is not finished yet because we had a delay that was in our starting question, which then we plug in as the 3 minus 3 here to get this value, which was the parametric equation. Now, for our second task, we are asked to get the circular motion of it's just a circular motion, sorry. It's initially at the position 3, 3, and it takes 180 seconds to complete a circular motion of radius 4 around a certain point of minus 1, 3. Okay, so what the position or which the order of precedence between the sine and the cos are very important, because to get the clockwise motion we have x equals sine and y equals cos. Now, if we wanted to get the anti-clockwise, which in this question we have done, we need to get the cos as the x and the sine as the y. Now, in a normal circular motion, it's 360 seconds, but in this we have to do it in 180. So that means we have to multiply our t, which is our 360, by 2 to get half the time. Now, we have we have the radius of each of the circular point is 4, and this, see, if coming from our x is our cos, so then we multiply our radians, we'll multiply our t value by 2 to get our 180, and then we put in our position of where the circular motion will begin, or the circular motion will motion around, which is our minus 1, 3. Okay, then, talking about our straight line motion again. Now, it is very, very important to keep at a constant our y value in this, because our straight line motion will be motioning around, will not be bouncing, but it will be coming back and forth for the y-axis. Now, when we keep our y at a constant, it will motion left and right or over and back past um, our constant. It can be any number at all, whatever, at least as long as it's a constant. Now we use we use sine to get our points in our straight line motion. Now we have to get, in a straight line motion it'll be 360, and we plug in each value. We can split it up however we want, however we like, and we have our values here. Now, the bounce motion is very, very alike the straight line motion, except it'll not be running on any sort of a horizontal axis, but are running on a vertical axis. And how we do this is, instead of keeping y at a constant, we'll be keeping x at a constant. So we'll be using the same constant. No, we'll be using 4, and we'll be using the same points just to describe all of the movement, or we can put into term all of the movement that both will be doing. Now, okay, so this is different than the other movements because of the curvature of the movement. Now, to do this, we have our we do keep a constant, but our constant will be moving. Now, our constant will be moving through time. Well, not be moving through time, but will be moving at time. And now, to get this, we will be multiplying our value of t, which is our time, by the value of the constant. Now, the constant will be all the same throughout, but as the time moves, the constant will also move. Now, as you can see here, our time is moving here, throughout here, and also so is our constants. So as our time are moving, our constants are swaying back and forth, a lot like our bounce movement and a lot like our straight line movement. But instead of the straight line, we'll be having a curvature. Thank you.